Dear students, welcome to Build the Basics YouTube channel. Today, let me answer this basic question whether reactive power is useful or useless power. Let's go into the details. We all have learned from the books that there are three components of power. So number one is active power and reactive power, and together they form apparent power. And they form a power triangle together. So we also have been told that the active power is the actual power consumed by the load, and it is only the useful power, and the rest of the power is useless. But in this video, I want to highlight whether the other component of the power, that is the reactive power, is really useless or not. Now let's talk about basics of power transmission. As you know, the generating stations generate electric power, and this power is transmitted to load centers using transmission lines and to the customers through power distribution network. So in this process, the power generated by the generating station is not fully consumed by the loads because there is some power loss resulted in the transmission and distribution networks, mainly due to the line internal resistance and also the current flowing through the transmission lines. So this is called as I square R losses. Actually, you cannot avoid this current flow due to the power demand in the load centers because current is required in the load centers. But the problem is, on top of the normal current, there will be some additional currents due to the reactive nature of the transmission lines, and this additional therefore the additional loss also results. So this will further increase the losses in the transmission lines and also voltage drop across the line. Basically, this is the drawback of additional current due to the reactive power. Then what is the advantage of reactive power? Can't we avoid this current in the transmission lines due to reactive power? The answers to these questions are explained in this video. First of all, don't forget to subscribe to Build the Basics YouTube channel and click on the bell button to watch such interesting videos in the future. We need to learn some basics first before getting into the details of reactive power. There are basically two types of loads. So they are resistive load and reactive loads. So the resistive loads consumes electrical energy. The examples of resistive loads are the heaters, light bulbs, and also most domestic appliances like fans or heaters or refrigerators, but under load. Because if they are under load or fully loaded, then they're predominantly resistive. Remember, under no load condition, the situation is different, which I will explain later. The second type of load is reactive loads. The reactive loads are they store electrical energy temporarily and they feed it back to the source. So they don't consume any electrical energy. So reactive loads are two types. First one is inductive type and capacitive type. Examples of reactive loads are motor on low load or no load condition because it mainly acts like a reactive load. It consumes reactive power, and also transformers and also reactors in the substations and line inductance of transmission lines. Also line capacitance of the other type of reactive load is capacitive. That then line capacitance of the transmission line and compensation capacitors of the power system and compensation converters also. They also act as reactive loads. So remember, both reactive and resistive loads draw current when constant voltage or current is applied. But in real world, every load is mix of resistive and reactive loads. You cannot find only resistive load or only reactive loads. They are always combination of these two. Now coming back to the basic question, whether reactive power is useful power or useless power, my answer is the reactive power is is really useful power. It is not useless. In fact, it is very useful and essential in our daily electrical energy consumption process. Reactive power is needed to produce two important electrical phenomena called as magnetic field and electric fields. So if you see, most of our machines and equipment work on electromagnetic induction principle. In generators and transformers, the voltage is induced due to magnetic fields, and in motors, torque is produced due to magnetic fields. Therefore, most of the equipment consume the reactive power. The motor needs to establish and maintain rotating magnetic field to rotate the rotor, thereby driving the mechanical motion. The rotor magnetic field of the motor is established by taking reactive power from the source. Similarly, the transformer also needs reactive power to generate magnetic field in the primary coil of the transformer and induce voltage in the secondary coil. Therefore, if the reactive power supply is not adequate, the motor will not rotate and transformer will not transform voltages. And most of the passive filters do not work in the power system. So now let's talk about other equipment that produce reactive power. The reactive power is produced by lightly loaded transmission lines because they are capacitive in nature, or synchronous machines, or static capacitors, etc. Basically, capacitors store electrical energy in the form of electric field. So we use reactive power again, one reactive power against another reactive power, because to compensate lagging reactive power or reactive power consumed by the inductive nature of the load, we use capacitors to compensate that reactive power, because capacitors basically produce reactive power. So by controlling this reactive power, we can also control the voltage in the power system. For example, we use the shunt inductors to minimize the voltage rise due to Ferranti effect. You know, Ferranti effect. Ferranti effect, basically the receiving end voltage of the transmission line will increase due to the particularly in lightly loaded condition. So to compensate the minimize the Ferranti effect, we use shunt inductors to minimize the voltage rise, and also we use sometimes shunt capacitors to improve the voltage profile at the load centers. Therefore, without reactive power, most of the power system equipment and consumer loads will not work. So reactive power, the conclusion is reactive power is very useful in power system. However, there is a need for reactive power compensation in the power system to balance the reactive power consumption and production. So instead of transmitting the reactive power from generating stations to the load centers, because it results in additional losses and voltage drop, what you can do is generate reactive power at the places of its requirement. So this avoids transmitting through the lines, and this is called as reactive power control. So this reactive power control basically helps in reducing the losses in the lines due to the additional current flowing through the lines, and also voltage drop, as I mentioned before. So thank you very much, and this is about reactive power. I hope the video is helpful for you to understand the basics of reactive power. So subscribe to Build the Basics YouTube channel, and wait for more videos in future. Thank you.